Example 22.2 says to write the first four terms of the sequence whose nth term or general term is given by, and then we have two different sequences defined for us. So the main instruction here is to write the first four terms of the sequence. So what we've described here in part A is a sequence called AN. AN is 2n plus 5. And since we're only looking for the first four terms, what we're looking to do is work with a finite sequence here. So let me calculate the first term. That's going to be A1. We don't necessarily have to go through the table formatting to be able to write out all these terms. Since we're only going to be plugging in natural numbers anyway, the place that we start is the first. So we'll plug in 1. That'll be 2 times 1 plus 5 for a grand total of 7. A2, 2 times 2 plus 5 for 9. A3 will be 2 times 3 plus 5, which is 11. And then A4 will be 2 times 4 plus 5, giving us 13. Again, only the first four terms. Now, what's typically done in a sequence setting, when we're asked to write the first four terms, we will list the four terms separated by comma horizontally. And it will look like this. So that's my final box end answer there. That is for sequence AN, or sequence A. On part B, I have another sequence defined, and it is BN. This would be analogous to what we do in the previous sections, f of x and g of x, or h of x and k of x. It's just a way of naming the function. And so BN is just another name for the function, or for the sequence, which is a type of function. So again, we're going to be substituting in for the first four natural numbers. So B1, -1 to the first, over 2 to the first plus 1. In the numerator, -1 to the first will just be -1. In the denominator, 2 to the first power plus 1 would be 3. And that looks like a simplified fraction, -1/3. So there's your term value. B2 will be -1 squared divided by 2 squared plus 1. So when I square -1, it's going to turn it into +1, and then 2 squared plus 1 in the denominator will be 5, and that's also a reduced fraction, so the second term is 1/5. B3 will be -1 to the third divided by 2 cubed plus 1. So that goes back to being a -1 for the numerator, and 2 cubed plus 1 will give us 9 for the denominator. And what -1/9 is our third term. And then finally for B4, -1 to the fourth divided by 2 to the fourth plus 1, +1 for the numerator, and 17 for the denominator. Writing these out as a list, -1/3, comma 1/5, comma -1/9, comma 1/17. And this is an interesting sequence because of this -1 raised to the n. You should have noticed that every other term was positive or negative. And so there's this alternating between positive and negative that occurs in this sequence. And if we continue to go beyond the first four terms, that pattern would continue as well. So because of this -1 to the n, we have this alternating feel, which means that this is a alternating sequence, which is something that you don't get in a traditional function that we've seen all throughout the semester. When I say traditional function, I mean a continuous function, not one that is discrete.